Moderate resolution imaging spectrometer, known as MODIS, represents an important tool in the study of changes and interactions occurring in the Earth's environment. The instrument will provide nearly complete two-day coverage of land, oceanic, and atmospheric phenomena. The MODIS instrument on the EOS AM-1 spacecraft maintains a descending polar Earth orbit at an inclination of 98.2 degrees and an altitude of 705 kilometers. The removal of the thermal blanket reveals the components which make up the MODIS instrument. These include the solar diffuser, the forward viewing analog electronics module, and the main electronics module. Behind the radiative cooler cover is the radiative cooler, the space viewing analog electronics module, and the scan cavity cover. Within the scan cavity are the scan mirror, black body, solar diffuser, and the entrance aperture of the spectroradiometric calibration assembly. On the forward side of the MODIS mainframe are the scan motor, solar diffuser stability monitor, and spectroradiometric calibration assembly. Spanning the width of MODIS is a two-mirror off-axis afocal Gregorian telescope. The aft optics are located behind the telescope and consist of a dichroic beam splitter assembly and 4 optical objectives with focal plane assemblies. MODIS will acquire photoradiometric data of the Earth's environment. The instrument's instantaneous field of view is directed by the scan mirror, first onto the fold mirror, then onto the primary mirror of the telescope, through the field stop, and finally onto the secondary mirror. The dichroic beam splitter assembly then splits the light to the 4 optical objective and focal plane assemblies. There is an assembly for the near-infrared spectral bands and one for the visible spectral bands. Cooled focal plane assemblies detect the short and mid-wave infrared spectral bands and the long-wave infrared spectral bands. To ensure the validity of acquired data, MODIS has a full complement of calibration devices. There is a black body and a view of space, which provides a 2-point thermal calibration. Visible and near-infrared radiometric calibration requires the solar diffuser, which provides diffuse solar illumination to the scan mirror. The spectroradiometric calibration assembly, or SRCA, provides spectral calibration, radiometric calibration, and spatial registration knowledge of MODIS bands. Radiometric calibration is accomplished using light generated by the spherical integrating source, or SIS, which passes through the open position on the source filter wheel and through the monochromator via a plane mirror positioned in place of the diffraction grating. The light exits the monochromator, passes through the collimator, and onto the exit fold mirror, which reflects the beam out of the SRCA and onto the scan mirror. The spatial calibration light path differs from that of radiometric calibration. The light generated by the SIS is combined with infrared light by the filter wheel's beam combiner. At the exit of the monochromator, the combined beam passes through 2 spatial reticle patterns to measure cross-track and along-track band-to-band registration. The spectral calibration light path also differs from that of radiometric calibration. The light generated by the SIS passes through one of the filter wheel's order sorting filters, is focused by the relay mirror, and passes on to the entrance slit. The light is then diffracted by the grating in the monochromator and passes through the exit slit. Another calibrator, the solar diffuser stability monitor, tracks changes in diffuser spectral reflectance. Through the use of its multi-position fold mirror, it monitors the solar diffuser, the direct sun, and black surround in 9 spectral bands. Over the coming decades, MODIS will provide a global data set that will enhance our understanding of the changing world.